So based on different types of vectors by solving some problems. Now the question is classify the following measures as a scalar and vector. Classify whether it is vector or scalar, you have to identify. Okay. Now first one is 10 kg. Is it scalar or vector? You know the definition of vector and scalar. A quantity which has only magnitude, that is known as scalar, whereas a quantity which has both magnitude and direction, that is known as vector. Now what about 10 kg? Is it scalar or vector? That is 10 kg. That is scalar quantity. What about 2 meter northwest? 2 meter northwest. That is magnitude as well as direction. Northwest, both that is there. That is vector. What about 40 degrees centigrade? It is scalar quantity. One more question. 20 meter per second square. Meter per second square belongs to under velocity. So velocity is vector, isn't it? Time period. Time. What is time now? 8 o'clock, 6 o'clock, that is number. So that is scalar. 40 watt electric charge. Do you know 40 watt electric charge? That is vector. Then distance, length. Distance is in length, that is scalar. What about force? Vector. What about velocity? Vector. Work done. Work done. Scalar quantity. Classify the following results are vector or scalar. 10 kg scalar quantity, 2 meter northwest vector, 40 degree centigrade scalar quantity, 20 meter per second square belongs to under velocity, that is vector, that is acceleration vector, time period scalar quantity, 40 watt electric charge, that is vector, distance, that is length, scalar, force is vector, velocity, that is also vector, and work done is scalar quantity. Each question carries 1 mark. Identify the following results are scalar or vector. Okay. Now question number 2. Second question says, write, note down, write the magnitude of the vector, following vectors. First one, A is the vector I plus j plus k. Second problem, B is the vector 2i minus 7j minus 3k. Then third one, C is the vector 1 bar root 3i plus 1 bar root 3j plus 1 bar root 3k. To find the magnitude of the following vectors. One more question. How to solve? A is the vector I plus j plus k. To find the magnitude of A, that is magnitude of A denoted by two notations, that is modulus notation. Read it as magnitude of A. What is the formula for magnitude of A? Under root of coefficient of I, coefficient of j, coefficient of k. Coefficient of I 1 square 1. Coefficient of j 1 square 1, coefficient of k 1 square 1, that is equal to 1 square plus 1 square plus 1 square, that is root 3. What about second problem? Magnitude of B is equal to under root of coefficient of I 2 square plus coefficient of k minus 7 square plus coefficient of k minus 3 square, that equals root of 4 minus 7 square 49 minus 3 square 9, that equals root of 49 plus 9 58, 58 plus 4 62, right? What about third one? What is magnitude of vector C? Under root of coefficient of I 1 by root 3 its square, that is 1 by 3 plus 1 by 3 again plus 1 by root 3, sorry, that is 3, that equals LCM is 3, 1 plus 1 plus 1 3, 3 by 3 1. Each question carries 1 mark. Then third problem, write two different vectors having same magnitude. Write two different vectors having same magnitude. Take two vectors having same magnitude. ಎರಡು vectors magnitude same ಇರಬೇಕು. Take any one vector. Suppose let A is the vector. You take any one vector. Say 2i plus 3j plus 4. Or if you take I plus 2j plus 3k, you take any one vector. Write the vector having same magnitude. Now here magnitude of A is equal to how much? How to write magnitude of A? You know, that is under root of coefficient of I 2 square 4, coefficient of J 3 square 9, coefficient of K 4 square 60. That is equal to how much? Root 29. Similarly, to find one more vector having its magnitude is also same. How to write? B is the vector. What can you do? Just interchange the numbers. Say if you take 3r plus 4j plus 2, right? Just you interchange those numbers, isn't it? So to find its magnitude, so magnitude of B is equal to under root of 3 square 9, 4 square 16, 2 square 4, that is root 29. Write two different vectors having same magnitude. You take any one vector, another vector by taking, just you interchange the numbers. It will become having same magnitude. Either you take plus or minus, no change, isn't it? So whereas similarly, fourth question, write two different vectors. Write two different vectors having same direction. Having same direction. Both the vectors having same direction. That is known as like vectors. Again, if you take any one vector, suppose that A is the vector I plus 2j plus 3k. Take any one vector. Okay. Having same direction, but not same magnitude. Only having same direction. So what can you do? Take another vector, B vector. If you multiply by any one number, if you take 2 or if you take 3, you take multiply by any one number. If you take multiply by 2, that is 2i plus 4j plus 2 3s are 6k. Multiply that equation vector A by 2, it will become 2i plus 4j plus 6k. Now both the vectors having same magnitude, isn't it? That is equal to, how? Take 2 common, I plus 2j plus 3k, that is 2 into I plus 2j plus 3k is nothing but vector A. Both the vectors having same direction, that is known as like vectors. So remember, write two different vectors having same direction. ಕೇಳಿದಾಗ ಏನು ಮಾಡಬೇಕು? ಯಾವುದಾದರೂ ಒಂದು ವೆಕ್ಟರ್ ತಗೊಳ್ಳಿ, ಇನ್ನೊಂದು ವೆಕ್ಟರ್ ಏನು ಮಾಡಬೇಕು? ಆ ವೆಕ್ಟರ್ ಯಾವುದಾದರೂ ಒಂದು ನಂಬರಿಂದ ಮಲ್ಟಿಪ್ಲೈ. ವೇರಸ್ ಹ್ಯಾವಿಂಗ್ ಸೇಮ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಕೇಳಿದಾಗ ಏನು ಮಾಡಬೇಕು? ಒಂದು ವೆಕ್ಟರ್ ತಗೊಂಡಿರ್ತೀರಲ್ಲ, ಇನ್ನೊಂದು ವೆಕ್ಟರ್ ಏನು ಮಾಡಬೇಕು? ಆ ವೆಕ್ಟರ್ ಎ ದಲ್ಲಿ ಇರತಕ್ಕಂತ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನು ಇಂಟರ್ಚೇಂಜ್ ಮಾಡಿ ಬರೀಬೇಕು. This is having same magnitude, that is having same direction. Here, find the value of x and y so that the vector 2i plus 3j and xi plus yj are equal. Both the vectors are equal, then to find the value of x and y, very simple. Given 2i plus 3j is equal to xi plus yj. Now equating the coefficients of I and j in LHS and RHS. Coefficient of I 2, here coefficient of x, therefore x is equal to 2 and here y is equal to 3. 1 mark. Whereas next question is, find the scalar and vector component vector. Find the scalar and vector component of vector with initial point 2, 1 and terminal point minus 5, 7. Now 2 points are given. This is A point, that is B point. A is the point 2, 1, B be a point minus 5 comma 7. This is initial, that is terminal point. Okay. Now to find the vector AB. Vector AB is equal to, how to write vector AB using position vector formula? AB vector is equal to OB minus OA. Now here B is the point 5 comma 7. What is OB vector? By taking I and j, so that minus 5I plus 7j, right? This is position vector. Minus A is the point 2 comma 1. OA position vector, by taking I and j, 2I plus 1j. Then simplify, minus 5I minus 2I minus 7I plus 7j minus 1j plus 6j. Therefore, scalar is not real number. So scalar component is minus 7 comma 6. What is vector component? This is minus 7i plus 6j is the vector component. Vector component means by taking I and j. Scalar component means by eliminating I and j. Okay. This is second one. Then third one more question. Find the unit vector in the direction of the vector A. You know the formula. Now first problem. A is the vector I plus j plus 2k. Find the unit vector in the direction of given vector. You know the formula. Unit vector in the direction of given vector is denoted by A cap and is defined as the ratio of the vector A and their magnitude. That is equal to vector A is I plus j plus 2k divided by magnitude of A under root of coefficient of I 1 square 1, coefficient of j 1 square 1, coefficient of k 2 square is 4. That is I plus j plus 2k divided by under root of 1 square 1 plus 1 2 square 4, totally 6. Similarly, second problem, same type. Find the unit vector in the direction of the given vector denoted by A cap is equal to formula vector A by their magnitude, that equals vector A 2I cap plus j cap plus 3k cap divided by magnitude of A under root of coefficient of I 2 square 4, coefficient of j 1 square 1, coefficient of k 3 square 9. That equals 2I plus j plus 3k divided by root 14. Each question carries 1 mark. Similarly, fourth problem. Find the unit vector in the direction of the vector PQ. Initial point given, terminal point given. Now here given P is the point 1, 2, 3, Q is the point 4, 5, 6. Therefore, first to find vector PQ. Vector PQ is equal to, using position vector we write OQ minus OP. OQ is the point 4, 5, 6. Therefore, position vector OQ is equal to 4I plus 5j plus 6k. Correct? Minus OP 1I plus 2j plus 3k. Subtract 4I minus 1I 3I, 5j minus 2j 3j, 6k minus 3k plus 3k. This is position vector PQ. Now the question is unit vector in the direction of PQ. Now put PQ is equal to, let PQ is equal to vector A. You call it as vector A. We got one vector. Therefore, unit vector in the direction of PQ vector is denoted by A cap is equal to vector A by their magnitude. What is vector A? Here PQ cap is equal to vector PQ divided by magnitude of PQ. That is vector PQ is 3I plus 3j plus 3k divided by magnitude of PQ under root of coefficient of I 3 square 9, again 3 square 9, 3 square 9, take 3 common, I plus j plus k divided by 9 plus 9 plus 9, 27. 27 can be written as 9 into 3, but square root of 9 is 3 root 3, 3 cancel, we get I plus j plus k by root 3 is the unit vector in the direction of PQ vector. Similarly, same question, here multiplication, here next question is addition. Find the unit vector in the direction of sum of two vectors. Now first to find a plus b vector. What is a plus b vector? Adding the corresponding vectors. 2i minus 1i, 1i. Minus j plus j cancel, that is 0j. Plus 2k minus 1k plus 1k. That a plus b vector, let a plus b vector denoted by p vector. Let p is equal to vector a plus b. That is 1i plus 0j plus 1k. Therefore, unit vector in the direction of a plus b. A plus b is equal to p. So again you know the formula p cap. P cap is nothing but a plus b cap is equal to vector p divided by magnitude of p. Vector p means a plus b divided by magnitude of p. Magnitude of a plus b. Now a plus b value I plus 0j plus k divided by magnitude of a plus b under root of coefficient of I 1 square 1, coefficient of j 0 square 0, coefficient of k 1 square 1, that is I plus 0j is nothing but 0, then k divided by root 2. This is unit vector in the direction of sum of two vectors. That is unit vector in the direction of product of two vectors. Clear? So these are problem 4th and problem 5th 2 mark question. Problem 1, 2, 3 are again problem 2 is also 2 mark. Problem 1 and 3 1 mark question. Okay? Next problem. Find a vector in the direction of vector 5y minus a plus 2k which has magnitude 8 units. Find the vector in the direction of the vector. Now here a is the vector 5i minus j plus 2k. Now to find the vector in the direction of the given vector denoted by a, as you know that unit vector in the direction of vector a denoted by, what is the formula? A cap is equal to vector a by their magnitude. This is the unit vector in the direction of the given vector. Has its magnitude is 8 units. Therefore to find this is unit vector in the direction of given vector has its magnitude is 8 units. That is 8 times a cap. To find 8 times a cap, that is a cap formula vector a by the magnitude. What is vector a? 5i minus a plus 2k, right? Divided by its magnitude. Magnitude of a is under root of coefficient of I square 25, coefficient of j minus 1 square 1, coefficient of k 2 square 4. That equals 8 into 5i minus j plus 2k divided by 25 plus 1, 26 plus 4, root 30. This is the unit vector in the direction of given vector has its magnitude is 8 units. 8 into a cap. 2 mark question. Whereas 7th question, that question was asked in 2016 March, 1 mark question. If the vector AB is equal to 2i minus a plus k and vector OB is equal to position vector OB is equal to 3i minus 4j plus 4k. Now the question, find the position vector OA. Now here vector given data vector AB is equal to 2i minus j plus k. Now to find the position vector OA, as you know that AB vector using position vector how to write OB minus OA, right, is equal to 2i minus j plus k. In left hand side AB vector is equal to OB minus OA is equal to as it is. Now therefore using this to find the vector OA, rearrange vector OA is equal to what happened? OB minus 2i minus j plus k, right? Rearrange vector OA is equal to OB, that term goes to left side, minus 2i minus j plus k. Now that is therefore OA vector is equal to OB vector 3i minus 4j plus 4k minus 2i minus j plus k. Simplify. Therefore, OA vector is equal to 3i minus 2i, 1i. Minus 4j minus of minus j plus j, that is minus 3j. 4k minus k, that is plus 3k. This is the position vector OA. 2016, 1 mark. Whereas next question, show that the vectors, two vectors are collinear or parallel. You know the condition. Two vectors are given. Let A is the vector given data 2i minus 3j plus 4k. B vector is equal to minus 4i plus 6j minus 8. Show that these two vectors are collinear or parallel. You know the condition. When you say that two vectors are parallel, what is the condition? A1 by A2 equals B1 by B2 equals C1 by C2. Here it is in the form A1i plus B1j plus C1k. Here A1 is equal to 2, B1 is equal to minus 3, C1 is equal to 4. Similar B vector A2i plus B2j plus C2k. A2 value minus 4, B2 value 6, C2 value is minus 8. Now take one by one. Now A1 by A2 is equal to how much? 2 by A2 value minus 4, that is minus 1 by 2. B1 by B2, what is B1? Minus 3 by B2 is 6, that is minus 1 by 2. And C1 by C2, C1 is 4, C2 is minus 8, again minus 1 by 2. All values are equal. Therefore, A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Hence, two vectors are parallel. Remember the condition. If two vectors are parallel, condition A1 by A2 equals B1 by B2 equals C1 by C2. Or one more condition, one vector is equal to some constant lambda into another vector. Whereas next problem is, show that the points with position vectors, three position vectors are given, are the vertices of right angled triangle. Are the vertices of right angled triangle. Now here three position vectors are given. Now given data. First position vector denoted by, say, let OA is the position vector 2i minus j plus k. OB is the position vector, second position vector I minus 3j minus 5. Then OC is the position vector 3i minus 4j minus 4. Three position vectors are given. Using these three position vectors, to prove that triangle ABC is right angled triangle. Right angled means Pythagoras concept satisfied. What is Pythagoras theorem? The square of the hypotenuse is equal to sum of the squares of other two sides. Sum of the squares of other two sides. Now to prove that AB square plus BC square is equal to AC square, or BC square plus AB square is equal to AC square. Okay, the square of the hypotenuse is equal to sum of the squares of other two sides. Now what can you do? First to find one by one. Now to find AB vector. How to write AB vector? Using position vector. You know, OB minus OA. Subtract. This is OB, that is OA. Subtract 1i minus 2i, that is minus I, right? Minus 3j minus of minus j plus j, that is minus 2j. Minus 5k minus k, that is minus 6k. This is AB vector. Then to find its magnitude. Now magnitude of AB is equal to under root of coefficient of minus I 1 square 1, coefficient of j minus 2 square 4, coefficient of k minus 6 square 36, that is root 41. Next to find BC vector. Now BC is equal to, using position vector, OC minus OB. You know OC vector and OB vector. Subtract 3i minus I, 2i. Minus 4j minus of minus 3j plus j, that is minus 3. Right? Then minus 4k minus of minus 5k plus 5k, that is 1. Then magnitude of BC is equal to under root of coefficient of I 2 square 4, coefficient of j minus 1 square 1 plus 1, that is root 6. Similarly, to find CA. CA is equal to OA minus OC. That is OA minus OC. Subtract 2i minus 3i minus r. Minus j minus of minus 4j plus 4j, that is plus 3j. 1k minus of minus 4k plus 5k. Therefore, magnitude of CA is equal to under root of 1 coefficient of I minus 1 square 1, coefficient of j 3 square 9 plus 25, that is root 35. We got 3 magnitudes. Observe this. Now, BC square or magnitude of BC square plus magnitude of CA square is equal to, what is magnitude of BC? Root 6. Its square 6. That is magnitude of CA root 35. Its square 35. 35 plus 6, 41. Clearly 41 is the value of magnitude of AB square. Therefore, AB square is equal to, hence AB square is equal to BC square plus CA square. Pythagoras theorem satisfied. Hence, triangle ABC is right angled triangle. Right angled triangle. That is 2 mark question. Okay. So this is 2 mark question. Triangle ABC is right angled triangle. Next problem. 1 mark question. If the vectors, 2 vectors are parallel, find the value of m. You know the condition. If 2 vectors are parallel, condition a1 by a2 equals b1 by b2 equals c1 by c2. Now here vector A is given 2i plus 3j minus 6k. Vector B is given 4i minus mj minus 12k. Therefore, vector A is parallel to vector B. That is given, parallel. Therefore, this implies condition a1 by a2 equals b1 by b2 equals c1 by c2. Implies, what is a1? 2, a2 4 is equal to b1 3, b2 minus m is equal to c1 minus 6, c2 minus 12. Simplify, that is 2 by 4 is nothing but 1 by 2 is equal to 3 by minus m, that is equal to 1 by 2. All terms are same. Now therefore 3 by minus m is equal to 1 by 2. Cross multiply, minus m into 1 minus m is equal to 3 2s are 6. Therefore m is equal to minus 6. 1 mark question. Okay. Now next question is, find the angle between 2 vectors A and B with magnitudes are root 3 and root 2 respectively, having dot product A dot B is equal to root 6. Now here A dot B is given, so to find the angle between, if it is dot product is given, which formula you can apply here? Cos theta. Because dot product is given, so you know that angle between the vector cos theta is equal to, what is the formula? A dot B divided by magnitude of A into magnitude of B. That is A dot B value given root 6. Magnitude of A is root 3 into magnitude of B is root 2. That is root 6 divided by root 6. Those two terms get cancelled. 1. Cos theta value 1, but the question is angle. Therefore angle theta is equal to how much degree? 0 degree. So angle between two vectors is 0 degree. Clear? Next question, same type. Find the angle between the vectors. First problem, A is the vector I minus 2j plus 3k and B is the vector 3i minus 2j plus k. First problem. Now either you can apply cosine of the angle between, or you can apply sine of the angle angle between the vector. So easy method, you take cosine. Now cos theta is equal to, what is the formula? A dot B divided by magnitude of A into magnitude of B. What is dot product? Multiplying the corresponding elements. Coefficient of I1, here coefficient of I in vector B 3, plus coefficient of J minus 2, coefficient of J in vector B minus 2, coefficient of K in vector A 3, coefficient of K in vector B 1, divided by magnitude of A under root of coefficient of 1 square 1 minus 2 square 4, 3 square 9. Then magnitude of B, coefficient of I 3 square 9 minus 2 square 4 plus 1 square 1. That equals 3 minus into minus plus 4 plus 3 divided by root 14 into root 14. 4 plus 3 7 plus 3 10 divided by 14. Correct? So 2 5s are 2 7 are. That is 5 by 7. 5 by 7 is the value of cos theta. Therefore, angle theta is equal to, we write, that is not perfect angle, we write cos inverse of 5 by 7. Similarly, second problem, same type. Let A is the vector I plus J minus K, and B is the vector I minus J plus K. Then cos theta is equal to, angle between the vector cos theta is equal to A dot B divided by magnitude of A into magnitude of B. Now to find A dot B, definition of dot product, multiplying the corresponding elements, coefficient of I in vector A1, coefficient of I in vector B1, coefficient of J in vector A1, coefficient of J vector B minus 1, coefficient of K vector A minus 1, coefficient of K vector B1, divided by magnitude of A under root of 1 square, coefficient of I1, 1 square, plus 1 square, plus 1 square 1, here 1 square 1, minus 1 square 1, plus 1 square 1, 1 minus 1 divided by root 3 into root 3, that is minus 1 by root 3 into root 3, 3. So cos theta is equal to 1 minus 1 by root 3, angle theta is equal to cos inverse of minus 1 by 3, that is equal to, put 1 by 3, call it as x. It is in the form cos inverse of minus x. By using inverse trigonometry, properties of inverse trigonometry, cos inverse of minus x is equal to pi minus cos inverse of x, that is 1 by 3. Because this negative value, so that convert positive value, that's why by taking pi minus cos inverse of x, that is in inverse trigonometry formula. Okay? Problem. Find the projection of the vectors I minus j on the vector, another vector I plus j. Each question carries 2 marks, very important. They will be asking final exam. Expected, no doubt. Every year you type problem. So first one, given data. A is the vector I minus j. There is no k term, we write 0k. Okay. And B is the vector I plus j. Again there is no k term, we write 0 in k. Therefore, you know the formula. Projection of vector A on vector B. What is the formula? Is equal to A dot B divided by magnitude of B. A on B. A vector B vector may be the magnitude of B. That is A dot B. Definition of dot product. Multiplying the corresponding elements. Coefficient of I1 in vector A. Coefficient of I1 in vector B. Coefficient of J in vector A minus 1, coefficient of J in vector B1, coefficient of K in vector A 0, here vector B 0, divided by magnitude of B under root of coefficient of I 1 square 1, coefficient of J 1 square 1, coefficient of K 0 square 0, that is equal to 1 1s are 1 minus 1 plus 0 divided by root 2, 1 minus 1 0 by root 2, 0 by root 2 is nothing but 0. Similarly, second problem. A is the vector I plus 3j plus 7k, and B is the vector 7i minus j plus 8. Therefore, projection of vector A on vector B is equal to, what is the formula? Vector A dot B divided by their magnitude. A dot B, definition of dot product, multiplying the corresponding elements. Coefficient of I in vector A1, vector coefficient of I in vector B 7, coefficient of J in vector A 3, coefficient of J in vector B minus 1, coefficient of K vector A is 7, coefficient of K vector B is 8, divided by magnitude of B under root of 7 square 49 minus 1 square 1, 8 square 64, that is equal to 7 minus 3, 8 7 are 56, divided by how much? Root of 49 plus 1 50, 50 plus 64 114, that equals 7 minus 3 4 plus 56 60 divided by root of 114, that is projection of vector A on B. Whereas second problem, if A is the vector 5i minus j minus 3, B is the vector I plus 3j minus 5j, show that the vector A plus B and A minus B are perpendicular. First, to find A plus B vector. What is A plus B vector? Adding the corresponding numbers, 5i plus 1i 6i minus j plus 3j plus 2j minus 3k minus 5k minus 8k. What is A minus B vector? Subtracting the corresponding elements, 5i minus I 4i minus j minus 3j minus 4j minus 3k minus of minus 5k plus 5k, that is 2. Now here A plus B vector denoted by alpha vector, A minus B vector denoted by say beta vector. We got two vectors. Show that these two vectors are perpendicular. You know the condition. When you say that two vectors are perpendicular, its dot product become 0. That is important result. If A dot B is equal to 0, we conclude that one vector is perpendicular to another vector. Now alpha dot beta. What is alpha vector? A plus B. What is beta vector? A minus B. Alpha dot beta, dot product, multiplying the corresponding elements. Coefficient of I in vector A plus B 6. In coefficient of I in vector A minus B 4. Coefficient of J 2. Here coefficient of J is minus 4. Coefficient of K in vector A plus B minus 8. Coefficient of K in vector A minus B is 2. That is equal to 6 4s are 24. Minus 8 minus 16. 24 minus 8, 16 minus 16. 0. Dot product is equal to 0. We conclude that hence one vector A plus B is perpendicular to another vector A minus B. 2 mark question, important sum. These are all 2 mark questions. Similarly, third question, next problem is find the magnitude of two vectors A and B having the same magnitude such that angle between them is 60 degree. Their scalar product is 1 by 2. What is to be given? Find the magnitude of two vectors having the same magnitude. Both the vectors having same magnitude. So that given data, magnitude of A is equal to magnitude of B, because having same magnitude. Such that angle between them is 60 degree. Theta value is given 60 degree. And their scalar product is 1 by 2. Scalar product means A dot B, denoted by A dot B is 1 by 2. Dot product is given, theta is given, both the magnitudes are equal. Now which formula you can apply here? Which formula? Dot product is given. Apply cos theta. Cos theta is equal to A dot B divided by magnitude of A into magnitude of B. Implies cos theta value 60 degree is equal to A dot B value 1 by 2 divided by magnitude of A into magnitude of B. Magnitude of B is equal to magnitude of A. So we can write magnitude of A. Now this implies cos 60 degree value 1 by 2 is equal to 1 by 2 by magnitude of A to the power of 2. Right? Now cross multiply 1 by 2 magnitude of a to the power of 2 is equal to 1 by 2. Divide both sides by 1 by 2, magnitude of a is equal to 1 by 2 divided by 1 by 2. 1 by 2, 1 by 2 cancel 1. Therefore magnitude of a is equal to 1. Similarly, and what about magnitude of b? That is also 1 because both the magnitudes are equal. Again 2 mark. This is also 2 mark. One more problem. Show that each of the given 3 vectors is a unit vector. First part. And second part also they are mutually perpendicular to each other. Now first part. Now there are 3 vectors are given. Now given data, A is the vector, first vector, 1 by 7 of 2i plus 3j plus 6k. B is the vector, 1 by 7 of 3i minus 6j plus 2k. C is the vector, 1 by 7 of 6i plus 2j minus 3k. Show that these 3 vectors are unit vectors. You know the definition of unit vector. Definition of unit vector, a vector whose magnitude become 1. Now to prove that magnitude of A is equal to 1, magnitude of B is equal to 1, magnitude of C is equal to 1. Now take 1 by 1 magnitude. Now magnitude of A is equal to 1 by 7. Magnitude means under root of coefficient of I is 8, 2 square 4 plus 9 plus 36. 1 by 7 into root 49. That is 1 by 7, root 49 is 7, 7 cancel, 1. Next, magnitude of B, 1 by 7 under root of coefficient of I 3 square 9, coefficient of J minus 6 square 36, coefficient of K 2 square 4. That is 1 by 7 into root 36 plus 4, 40 plus 9, 49. That is 1 by 7 into root 14 is 7, 7 cancel, 1. Similarly, magnitude of C is equal to 1 by 7 under root of 6 square 36, 2 square 4, coefficient of K minus 3 square plus 9, that is 1 by 7 into root 49, 1 by 7 into 7, 7 cancel, 1. So each magnitude is 1, we conclude that hence the given vectors are unit vectors. First part is over. Second part is also show that they are mutually perpendicular to each other. The word mutually perpendicular to each other means to verify all 3 vectors. Now here we should prove that vector A is perpendicular to vector B, then vector B is perpendicular to vector C, and vector C is perpendicular to vector A. That is known as mutually perpendicular. ಎರಡನೇ ಅಷ್ಟೇ ನಾವು ವೆರಿಫೈ ಮಾಡಂಗಿಲ್ಲ, 3 ವೆಕ್ಟರ್ಸ್ ವೆರಿಫೈ ಮಾಡಬೇಕಾಗುತ್ತೆ ಇಲ್ಲಿ. Now because the word mutually perpendicular means to verify all 3 vectors. Now take one by one vector. Now first you take A dot B. Because perpendicular vector, you know that when you say that 2 vectors are perpendicular, dot product becomes 0. Now first to find A dot B. Now A dot B, 1 by 7 into 1 by 7, 1 by 49 into multiplying the corresponding elements. 2 coefficient of I is 2, here coefficient of I is 3, coefficient of J 3, here coefficient of J minus 6. Similarly coefficient of K is 6, coefficient of K is 2, 6 into 2. Simplify 1 by 49 into 2 3s are 6 minus 18 plus 12, 6 minus 18 minus 12 plus 12, 0 by 49, that is 0. A dot B is equal to 0. Therefore vector A is perpendicular to vector B. Therefore vector A perpendicular to vector B. Similarly, to find B dot C, that is 1 by 49. Again multiply the corresponding elements. 3 into 6, that is 18, minus 6 into 2, minus 12, 2 into minus 3, minus 6. That is 18 minus 12, 6 minus 6, 0 divided by 49, that is 0. Therefore vector B perpendicular to vector C. Also C dot B, that is 1 by 49, Again dot product of these two. 6 into 2, 12 plus coefficient of the 2, coefficient of the 3. 2 into 3, 6. Minus 3 into 6, minus 18. 12 plus 6, 18 minus 18, 0 divided by 49. That is 0. Therefore, vector C perpendicular to vector A. Hence, they are mutually perpendicular to each other. Mutually perpendicular to each other. Okay?